Hello, you are welcome to my channel, a channel created to help the students taking A-level programs such as IJMB and JUPEP, and even the students taking science courses in their first and second years in universities, polytechnics, and even college of education. Also, this channel is created to help the Jambite too. The Jambite will immensely benefit from this channel, because one thing I've found out about the students taking science courses in JAM, especially physics, is that in most cases they don't score high mark or even finish the question. I mean physics now particularly. Not because they don't know it, but at times it might be only the long method they know. So they need shortcut formulae in quotes that can help them to save time and even score high mark. So what I have done is to get a lot of shortcut formulae they can use, and I'll be dishing them out in this channel. So all you need to do is to subscribe, share, and like. Even though you are not a science student or science-oriented person, you might have people around you, people connected to you in one way or the other. They might need this thing. Please share it and subscribe. And God bless you as you do that. All right. Today, we want to look at the general introduction to A-level physics. Yes, advanced level physics. And I will be dwelling more on IJB syllabus and JUPEP syllabus. Yes, so let me start with IJB syllabus. As far as IJB physics is concerned, it is divided into three. Yes, into three. General introduction. So A-level physics. Don't mind my own physics. That's my own short way of writing physics. You know, physics is interesting. Eh? All right. So, as I was saying, IJMB physics is divided into three. We have Physics 101, or what we call paper 1. We have paper 2, the one we call Physics 102, and paper 3. In your final exam, paper 1 exam will be done separately. Paper 2 exam at different time. Paper 3 at different time. So as far as IJB is concerned, you are writing 3 exams for physics alone. The same thing with other subjects, other science subjects, chemistry, biology, even maths. So in paper 1, all the topics there are divided into three categories. So in paper 1, we have general physics and mechanics. General physics and mechanics. We have heat and properties of matter. And lastly, we have waves and vibrations. In paper 2, the topics there are also divided into 3. We have geometric optics, we have electricity and magnetism, and lastly we have modern physics, which comprises the atomic physics and the nuclear physics. Right? Paper 3, that is your practical, an alternative. And I divide that into 2. The first one called data analysis. And experimental physics. This is all about IGMB syllabus as far as physics is concerned. Right? Now, in your final exam, talking about IGMB now, you will be given 18 questions, theory or true. And these 18 questions are divided into 4 sections. Section A, B, C, and D. Section A, there are 10 questions there. You are to answer all. Section B, 2 questions. You choose one. Section C, 4 questions. You choose 2. Then section D, 2 questions. You choose 1. Let me summarize this using a table. I think that will help us. Let me use a table for that. Paper, section, mark per question, or let me put number of questions first. Number of question, number of the question you are expected to answer. Also, mark per question. Then total marks. Total marks. Alright. For paper 1 now, that's Physics 101. We have section A. In section A, there are 10 questions there. You are to answer all the 10 questions. Each question carries 4 marks. Since you are answering all, total marks for that section is what? 40 marks. Section B, we have 2 questions there. You choose 1. Each carries 20 marks. Since you are answering just 1, so that's 20 marks. Section C, there are 4 questions there. You choose 2. Each carries 20 marks as well. Since you are answering 2, that gives us 40 marks. Then section D, there are 2 questions there. You choose 1. Right? Each is 20 marks, and that is 20. So at the end of paper 1, total obtainable marks there is 120. 120 marks. The same method is used for paper 2. We have section A, 10 questions, answer all. Each is 4 marks, and that's 40. Section B, 2 questions. Each is, you have to answer 1. That's 20 marks. Then section C, 4 questions, answer 2, each is 20 marks. Section D, 2 questions, answer 1, 20 marks as well. So paper 2 also, total obtainable marks there is 120. For paper 3, that's your practical. They will give you 3 questions straight. You answer 2, but number 1 is compulsory. So no section, no A, no B. It's just 3 questions straight. You answer number 1 compulsory, then you choose between 2 and 3. You choose one there. But I will divide it into 2 because of the trend I'm following. I'll divide it into 2. I will call it section A and section B. Since the first one is compulsory, so let's create a section for that. So 1 question and it's compulsory, you answer that one. Each is 30 marks. So between 2 and 3, I call it section B. You choose one there also. No, there are 2 questions there, you choose one. Also 30 marks. So at the end of the whole physics, total obtainable marks is 300. 120 plus 120 plus 30 plus 30. That's 300. 300 marks. Now these 300 marks will be converted to 80%. It will be converted to what? 80%. So your percentage score now will be whatever you score over 300 times 80%. Of course, for you to have A or B or C, it has to be 100%, right? The remaining 20% is from your CA. So your CA is equivalent to 20%. It will convert to 20%, then it will be added to it. So if a student now scores anything from 70% and above, then that is A, and that is equivalent to 5 points. I want to believe that by now you should have known that IGMB is based on points. And total obtainable points in IGMB is 16. 16. Why is it 16? I will explain that. If a student scores 60 to 69%, that's B, and that's equivalent to 4 points. 50 to 59%, that's C, and that's 3 points. 45 to 49%, that's D, and that's 2 points. 40 to 44%, that's E, and that's 1 point. 0 to 39%, that's F, and that's 0. Now, in each subject, the highest point you can get there is 5. Let's say for physics, a student has 5 points, like he has A, which is 5 points. Chemistry, let's say he has A also, another 5 points. Maths or biology, you choose one. Or biology, let's say you have A there too, another 5 points. So total points is 15, right? Because this student does not have any F in his or her combination, AB Usaria, which is the moderator of the program, will give you 1 point. That is why total obtainable points in IGMB is 16 points. They will give you 1. But the moment a student can have F, they won't give you that 1 point. Let's say a student has A in physics, A in chemistry, F in maths. This is just 10 points. They will give you that 1 point. Right? So total obtainable point is what? 16. Okay? Now, all these sections, A, B, C, and D, the questions, where are they coming from? Let me quickly show you that too. Let me quickly show you that. For paper 1 now, for paper 1, all the 10 questions in section A are coming from every aspect of physics 1. Every aspect. So they just pick 10 randomly across all the topics. So section A, all the questions will come from general physics and mechanics, general physics and mechanics, heat and properties of matter, heat and properties of matter, then waves and vibrations, waves and vibrations. Section B, remember I told you there are 2 questions there, you choose one. The 2 questions are coming from general physics and mechanics only. General physics and mechanics only. Then section C, there are 4 questions there. You choose 2. All the 4 questions are coming from heat and properties of matter only. Heat and properties of matter. Then section D, 2 questions, answer 1. The 2 questions are coming from waves and vibration. Waves and vibrations only. Then paper 2 now. Paper 2. Section A. All the questions are coming from all the topics. They are coming from geometric optics, electricity and magnetism, then modern physics, right? Remember I told you, you don't do the exam at the same time. Paper 1 day, paper 2 another day. Okay? Section B now, 2 questions, answer 1. The 2 questions are coming from geometric optics only. Geometric optics only. Then section C, 4 questions, answer 2. All the 4 questions are coming from electricity and magnetism only. Then section D, 2 questions, answer 1. The 2 questions are coming from modern physics only. Atomic physics, nuclear physics. Then paper 3. Paper 3. I told you there are 3 questions straight. The first one is compulsory, right? That number 1 question is coming from data analysis. Remember, I went into section myself, so I call it section A. So just 1 question, compulsory data analysis. Here they will give you an equation, then give you a table, then you have to linearize the equation. Then after you linearize the equation, you now adjust the table You adjust you modify the table to suit the equation you've familiarized. Then you plot the graph. But the second question 2 and question 3, you carry out the experiment yourself. Then get your readings, plot the graph. So you choose one between question 2 and question 3. So I call that section B. That is coming from experimental physics. You carry out the experiment yourself, you get your readings. So this is how IGMB exam is being arranged. Let me quickly go to JUPEB. In JUPEB, all the physics are divided into 4 parts. We have physics 01, 02, 03, and 04. 4 parts. Okay? Into 4 parts. Right? So, one thing about JUPEB is that they have objective in their own. They have objective, 50 objective questions. JUPEB is moderated by Unilab. Okay? So this is how the whole syllabus is arranged. Physics 01. In Physics 01, they have the following topics there: general physics and mechanics, then properties of matter. Properties of matter. Physics 02, we have heat, wave, and optics there. Then 03, we have electricity and magnetism. Electricity and magnetism. Then 04, we have 04, we have modern physics. Modern physics. Then you now have to do practical. Practical. So this is how they arrange their own. Now, as I've said earlier, they have objective, 50 objective questions. Now, in the theory now, you are doing the exam once, 50 objective and theory once. All these ones you are doing it once. And they will give you 8 questions. 2 questions from each section. 2 questions from 01, 2 questions from 02, 2 questions from 03, 2 from 04. You will choose 1, 1, 1, 1. You answer 1, 1, 1, 1. So you are answering just 4 questions in theory. 50 objectives, 4 questions in theory. 1 from each section. And each carries 30 marks. 30 marks. So you do all these ones once, then you now do practical. Unlike IGMB, whereby you do physics 1 separate, physics 2 separate, then practical. Here it is just 2. Objective and theory once, then practical. Okay? Now, how do they map their own? The objective questions, they are 50, right? It will be reduced to half, so that's 25 marks. Theory, each is 10 marks. Since you are doing 4, we are answering 4 out of 8, 1 from each section. They will give you 2. Then you answer 1 from each section. Each is 10 marks, so that's 40 marks. Theory is 40 marks. Practical is just 2 questions. You answer all the 2. Carry out the experiment yourself for the 2. You get your readings, carry out the experiment, get your readings for the first question, come to the second one, carry out the experiment, get your readings, plot the graph for the 2 of them. Right? So, practical. And each question is 30 marks. So that's 20. 20 marks. Your CA now is 15 marks. So if you add this together, that will give you 100. 100 marks straight. That's how they divide it. So whatever you now score now, they now arrange it based on this. If you have 70 and above, that's A. 6 to 69, that's B. They now follow this. Also based on points. But here, total obtainable point here is 15. A from each subject. You know, we are doing just 3 subjects in both IGMB and GPEP. Just 3 subjects. So your own is 15. Alright? After you've known how the exam is being arranged, I think we can now start with the first one, with Physics 101. Let's start with paper 1. Let's start with paper 1 now. Physics 101. And we are starting with general physics. General physics. Okay? Physics 101. Physics 101. We're dealing with general physics now. General physics. And now we start with what is physics? What is physics? We've been doing this right from our O level. What is physics? There are various definitions for physics, but I'll just give you one. That people show us the aims of physics, and why we study physics. Okay? What is physics? Physics is defined as an aspect or branch, as a branch of science, that uses a combination of mathematics. A combination of mathematics, observations, and experiments. To do what? To study now look at something. We said it combines mathematics, observation, and what? Experiment. It means that for you to be very good at physics, you must have a good knowledge of mathematics. Okay? Alright? To study the practice, the changes, practice, interactions, and nature of the universe. From the very small to the very large. In order to get a set of rules, so as to generate or establish, so as to establish fundamental concepts as known facts. That is the aim of physics. It combines mathematics, observation, and experiment to study the changes, the properties, interactions, and the nature of the universe, the whole universe. From the very small, when we say very small, from atomic and subatomic particles, right? Atomic and subatomic level, to the very large, like the planets, the galaxies, the space, the cosmos as a whole. To do what? In order to get a set of rules so as to establish fundamental concepts as known facts. This definition is comprehensive. Yes. And the word physics itself literally means natural or physical. Why? Physics itself is obtained from, is coined from a Greek word called physical. Physical, which means natural or physical. Natural or physical. Right? Natural or physical. So it's an aspect of physical science. Okay? Let me quickly introduce you to branches of physics. We have a lot of branches of physics. Branches of physics. Branches of physics. We have some that study light, optics, light, and in most cases the main use of laser. So we have laser physics in optics, laser physics. We have those that study sound, acoustics, right? We have those that study astronomy. We have astronomy and astrophysics. Astronomy and astrophysics. We have those that study, we have where geology meets with physics, called geophysics. We have geophysics, right? We have black hole physics. Black hole physics. We have even quantum physics. Quantum physics. And quantum physics has a lot of diversification. A lot. Under quantum physics, you see have quantum optics. Quantum optics. We have quantum finance. Quantum finance, where they use quantum mechanics to study finance and economics. Okay? We have quantum gravity. And we have quantum electrodynamics. Okay? We still have medical physics. Physics is just too wide. a lot of branches. Medical physics, we still have even physics electronics. Physics electronics. We have nanotechnology. Nanotechnology. We have what is it called? Even robotics. Robotics. So many. Okay? Robotics, medical physics, electronics, and so on and so forth. The next big question now is, what do physicists study? Physicists, what do they study? Physicists study what we call physical quantities. They study what we call what? Physical quantities. Without the physical quantities, there are no physicists. Because that is what we study. Alright? So, the first topic, even in your own level, you will be taught, they taught you then how to do physical quantities. When we talk about fundamental quantities and derived quantities, from there we move to unit and measurement. That's the beginning. That's the major thing we study in physics. Physical quantities. Physical quantities. So that's why we call it general physics. Physical quantities. Okay? That's the first topic there. After you know what physics is, the branches of physics, the first main topic we deal with is physical quantities. And what are physical quantities? A physical quantity is a number or set of numbers used for the quantitative description of a physical property, of the physical properties of a phenomenon, body or substance, and can be quantified by measurement. That is why physics is called science of measurement. We measure a lot, right? We say it is a number or a set of number used for what? Quantitative description of the physical properties of a phenomenon, a body or a substance, and can be what? Can be quantified by measurement. Anything we cannot measure, we don't have, like measure using apparatus, it does not concern physics. That is why if someone is sad or you are hungry, you don't go to a physicist. A physicist cannot help you. Why? He or she cannot quantify the degree of your sadness or the degree of the hunger. It can't help you. Though the psychologists might have their own way of measuring or determining the degree of sadness or emotional stuff and the rest. They might have their own way of determining those things by studying the person. But physicists, they can't help you because anything we cannot measure using apparatus, we don't have any business with it. That's why physics is basically called science of measurement. Okay? So, the physical quantities help us to describe the physical state of matter. Even though it has gone beyond that now. In our own level then, they told us physics is a branch of science that deals with the study of what? Physical aspect of matter. Why chemistry deals with the chemical aspect of matter. But physics has gone beyond just studying matter alone. We have antimatter now. We have dark matter. We even have dark energy. Right? Matter itself as the whole of the universe is just 5%. Dark matter is about 20%. While dark energy is about 75%. So physics is still evolving. Physics is evolving from just studying the fundamental nature of the universe. It has even gone into electronics. It has gone into computer, even medical physics, even quantum physics, quantum finance. Imagine using quantum mechanics to study finance and economics. Okay? So these are the things physicists study. They study what we call physical quantities. And these physical quantities, we said they are number. They usually go with what we call units, so as to differentiate one quantity from another quantity. And again, to give it a well-defined meaning. For instance, now if I look at you and I say, you are 10. You look at me, I'm 10. What do you mean? Am I 10 feet tall, or 10 years old, or I want 10 million? But if I put units, if I say 10 meter, the 10 is the number, while the meter is pointing us to distance or length. Right? So you know that I'm talking about length here. So the two together now make a well meaning of what? A physical quantity. Are we together? If I say 2 hours, the 2 is the number, while the hour is talking about time. So it tells us that the physical quantity we are dealing with here is time. So together now gives a well meaning of what? Of a physical quantity. So it differentiates this from this. I can also say 2 meter. Now 2. If there is no unit there, I won't know which one is talking about time, which one is talking about length. So in most cases, physical quantities go with what? Units. So as to define them uniquely. Are we together? Okay? And these physical quantities, they are classified majorly into 3 because there are so many. So many. Okay? Classification of physical quantities. They are classified into 3 majorly. We have fundamental and derived quantities. We have dimension and dimensionless quantities. Then we have scalar and vector quantities. And there are 2 special ones called supplementary quantities. They are just 2. Supplementary quantities. You can't classify them into any of these. So they are on their own. And they include They include plane angle, or simply called angle, which is measured in radian. The short form is rad. Then we have solid angle. Solid angle, measured in steradian. Steradian. Okay? Let's start with the first one. Fundamental and derived quantities. Alright? Fundamental and derived quantities. What are fundamental quantities? Let me write that. Fundamental, we can also call them basic quantities. Basic, or you call them independent quantities. Okay? Fundamental or basic quantities are the independent quantities. They are the independent quantities that cannot be derived. That cannot be derived or defined in terms of other quantities. In terms of other quantities. They are on their own. In fact, other quantities are obtained from them. They are the quantities that are independent of others and cannot be derived or defined in terms of other quantities. So their units also, their units are called fundamental units. Fundamental or basic or independent unit. Or we call them base unit. Fundamental or basic unit or independent units. Independent units. Or you call them basic units. Base units. You can also call them base units. Okay? And these fundamental quantities, they are 7 in number. 7 in number. I will list all of them. Here. Fundamental quantity. They are fundamental units. And the symbol we use for them, unit symbol. If you don't know the fundamental quantities, so do the derived quantities will be difficult. And again, you can't even get it on dimensional and dimensionless quantities. So they are very, very important. Fundamental quantities, we have length, and the unit of that is meter. Here we are using SI unit. SI unit. Now we have MKS system and CGS system. This is what we focus on. This is what we use. That is meter as unit of length, kilogram as unit of mass, second as unit of time. This one is centimeter as unit of length. gram as unit of what? Mass. Then seconds as unit of time. That is why conversion is needed whenever you are dealing with calculation. All the parameters must be in this unit before you can work with it. If they miss it, maybe one is in meter, one is in gram, you have to convert. And in most cases, you convert to the SI unit, standard one. This is what we call SI unit. That's the standard one. These ones are for lower values. This one is for higher values. Okay? So meter, symbol for that is small letter M. Then we have mass. Unit of mass is kilogram. Symbol of that is kg. We have time. Unit of time is second. And we use S for that. We have temperature. Unit of temperature is Kelvin. And that is K. We have electric current. Electric current. Whose unit is what? Ampere. Unit symbol is capital letter A. We have luminous intensity. Luminous intensity. Whose unit is candela? We use CD for that. Then lastly, we have amount of substance. Amount of substance. Whose unit is mole? We use MOL for that. These are all the fundamental quantities. 7 in number. 1, 2, 3, 4, 5, 6, 7. Okay? In fact, could you believe that we just answered IGMB question? 2015 question number 1. They said, state all the fundamental quantities, their units and unit symbol. Hence, state one significant difference between fundamental and derived quantities. 4 marks. So these are all the fundamental quantities we have. Okay? The unit symbol can also be called unit abbreviation. Alright? So let's go look at derived quantities. What are derived quantities? Derived quantities on the other hand. Quantities on the other hand. On the other hand, are the dependent quantities. Dependent quantities obtained by multiplying or dividing two or more fundamental quantities. Two or more what? Fundamental quantities. So they depend on fundamental quantities. They are obtained by multiplying or dividing two or more of them. Okay? That's why we call them dependent quantities. Their units also are called derived units. Their units are known as derived units. So, example of derived quantities are area, volume. In fact, all other quantities you can think of, apart from these 7 here, and apart from these 2, they are all derived quantities. Area, volume, density, power, energy, work, resistance, etc. They are all derived quantities. They are all derived quantities. Okay? In my next video, I'll be talking about dimension and dimensionless. Right? Dimension and dimensionless. Okay? We've talked about this one today. So we'll be talking more about the derived quantities when we get to dimension and dimensionless, because the derived quantities, some of them are dimensional, some of them are dimensionless. And any quantity that does not have units will surely be dimensionless. Alright? So please subscribe so that when next we upload any video, you'll be notified immediately. Okay? So next class we'll be talking about dimension and dimensionless. And if we look at these derived quantities, how are they? We said they are obtained from fundamental. How are they derived from fundamental? I will break everything down in our next video. Please do well to subscribe. Not only that, share it. Whether you're a science student or not, please share. If you're not a science student, don't just bypass it. There's a reason you come across it. And at times it might be that the people connected to you, people around you, might be in need of this. So subscription is free. Just click on it, subscribe, it's free. Then please do well to share. Have a blessed day. Love you. Thank you very much.